Welcome back, everyone. I'm Fleur. I'm a product specialist at BricsCAD, just like Frederick, and I will be carrying the next part of the session. So allow me to share my screen. We will wait 1 more minute for everyone to be surely returned behind their computers. And then I will start. In the meanwhile, I will share my screen with the agenda. Okay. So as you can see, we're now 2 hours in the meeting. We're at 10 CET, and we will be continuing until until 12 CET, so 2 more hours, and we will continue with 2 explanations, and then both each explanation followed by a breakout room again, where you can ask your questions. And today I'm the one presenting, or this morning I'm the one presenting in the after the break. And let me just open the chat here. Yes, I know it's not the same the same time zone everywhere. So I'm just telling the CET time zone, Central European time. Yeah, that's it. I think we can continue now, and I hope everyone returned. You can post extra questions in the chat, but it's better to keep them for the breakout rooms because you can have a closer talk. So that's what we will be doing. So we will start with the 3D constraints exercise, and let me grab the training manual, which you could find on 24/7, like discussed before by Frederick. So this is the training manual, and we're now at page 13 with 3D constraints. And we will start, I will recap quickly where you can find these on 24/7. So I will go and open BricsCAD 24/7. So again, if you don't have the training manual yet, which I do hope you have by now, but if you would have joined later, I will recap quickly. So you can go to the partner area, and there you will find the sales and training tools, the BricsCAD training, the BricsCAD mechanical training, of course, yes. And then we have V21. So that's the version we're working with currently. And then you're now here with the 3D constraints tab. And if you would look into that, you have again intermediate steps to help you along the way. And we have a step file. So that we will import, and that will require a communicator to work with. So as I leave this a bit on the side of my screen so that you can find it if you need to download it, and it doesn't want to minimize it for some reason. Yes, now it does. So it's this step file that we will need here. And that's how we are about to get started. And let me pop up here this one. Yes. So we're about to start a new drawing in BricsCAD, and then as I said before, you will need the communicator extension. If you don't have it, don't worry, we can you can always continue with the file step 1 DWG in the steps folder. So let me open BricsCAD again. I hope you still have it open. So just Yes, here we are. So again, we have the interface. We are working in the mechanical sphere, and here you at the bottom you can still change. And then we're opening a mechanical millimeter template. So yeah, make sure to choose it in the list of more templates if you don't have it yet. And then we're opening the mechanical millimeter template, and you just click the plus icon for a new drawing. Then the next step is to import the step file. For that, we need to check if our license of communicator is I get questions to make it full screen. Is this not full screen right now? Because for me it is. Okay,
yes,
now
it's full screen, yes.
Okay, thank you for the feedback. All right, so yes, we have now the BricsCAD interface with a new file, and we are going to import the step file. That is by checking your license level with the license manager command. So you can type it in, license manager, and then you see communicator is installed, so that's okay. And then you want to import. If you have communicator installed, it will add options to the import button here. So you press import, and you need to know that for this to locate the step file, there is a setting which says which file path the entire folder is saved to. And standard, this is the, I will just navigate upwards. This is the documents folder of your computer, where you will see a folder BricsCAD 24/7. If you have downloaded it regularly, if you have downloaded to some specific location on your computer, please navigate to that location, of course. But if you have downloaded through the 24/7 panel, it will create a folder BricsCAD 24/7. You can go in there. Then you go, of course, to the partner area folder, sales and training tools, BricsCAD mechanical, V21. And then we, as I hope you could locate this folder with all the exercises by now. Then you have the 3D constraints one, and there you will find the step file that you can open. And you will see that in the files of type list, you will now have more file types because communicator is installed. So that's how it works. And step is one of these file formats. So we click this one and we just open it. And then it will import. And once the import is successful, you should have something like this. Apparently, according some settings might make sure that it comes in as a block reference, or it might come in as a solid. If it's a solid, you're good to go. If it's a block reference, you might want to explode it to easily work further with me through the next parts of the exercise. So you can use the command explode by typing it in, or you could go to the, yeah, I don't know where it is exactly in the tabs. So you could also use the quad, and here you have also the little icon which says explode, and then you can explode it if it would be a block reference. If you would do this when it's a solid, then you will get regions, so make sure you don't have that. Remember, by pressing Control, you can select the entire solid, and you see here it's a 3D solid. If your if your detection of edges, faces, and boundaries was on, then you needed to press Control to select the entire solid. Otherwise, you just have to hover over it and it will highlight. So I will make sure that prioritization of faces is on, and so that it is easy to follow the next steps of the exercise. So what we do now is select the entire model. Again, hold down Control and click it, or you could make a selection box over it. A regular selection boxes will always select solids and not faces or lines. Then you can go to the Properties tab, and you can change the color to color 61. You can do that by selecting an extra color if it's not listed yet, and then you can select a color from the list. It's this one here. No, wait, here, sorry. This one here. Doesn't really matter that much, but you can choose a color of your liking. And then it's a bit easier to see the visual here. Okay. And then we want to go to step 5 of the training manual, and that is deleting the fillets. How do you do that? Easily, well, you can select the largest fillet of all of them. That is, for example, this corner here. And then you go through the quad. So you hover over the face, you go to the quad, and you go to the Select tab here. And there you select same or less radius fillets. So it's also in the Solid tab, and then in the Select menu here, you can use a lot of selection methods, such as these fillets. So then you select everything that is less, but I find it a little bit easier in the quad. So you again go to Select and select the less or equal radiuses or radii. And then you have all the fillets selected, as I have here now, and you can literally press the delete key to delete those fillets and make them restore in corners again. And then you should have something like this. So this is when you want to clean up a file, is an easy method to do so. So also for imported files, that is possible. Then we have an export of step 5, that is deleting these, how do you call them, depressions. And that is also done in the Select tab, and this time with the depression tool. It's a box with a rectangle drawn on top of it, or like, yeah, on top of it. And you can select that one. And then you will select from one face where you hovered over, you will select all the connected faces in that depression. So you can also do it at the side here and at the side here, for example. And then if you have selected all of them, you can again press the delete key, and same goes here. The depressions will just go away and you will have a cleaner model. Then we are here in the 3D constraints exercise, and we want to make constraints. So what do we do for that? We go to the Solid tab in the ribbon. And then you see the Parametrize tab and the Design Intent tab. You already used it with Frederick. We're going to use it again. So what we do is we select the bottom face here. Sorry, we select the command first, maybe. So we select the distance command. Then you are asked to select a first entity. We can select the bottom face here. Then a second entity, which can be the top face. And then you can type in a value, and you will see that it shifts from the first element I selected to the second one. That's the standard behavior. But if you have already other constraints in play on the same solid, this might be a bit different. So that is why when you do it the same here, it will work kind of the opposite way around. At least with me, it works the opposite way around. So here I know because of previous experience that it's easier to select this one first, and then this one. And then we also specify this distance of 15 here. And then it changes thickness. Now, these two that we already placed will be listed in the mechanical browser. That's if you wouldn't have that panel, you can right-click panels and mechanical browser to open it up. So right-click on empty space in your area and then go to panels and add the mechanical browser check mark. And then you have these two distances. When you click on them, they will give you a preview of what are the two faces in this distance constraint. And you can also right-click on this distance constraint and choose animate, and you will see a real-time animation of when this value would be changed, what would change in your component or in your model. And then we do, again, a last distance constraint from the top here to the bottom of this flange. So we have exactly the entire C shape as 15 thickness. So we just type in, you could also just accept the current value and later on change it with a parameter. But now we're going to first set it correctly and then link it to a parameter. So you can add 15, and then you will see that all of these flanges have 15 thickness. So now we're at step 8, and we can add a new parameter. How do you do that? Well, you can click on this icon here, user parameter, new parameter. Or you can go to the mechanical browser and click on the heading and then say add new parameter. And then by selecting it, you will see here the bottom part of the mechanical browser change. And you can give it a name, for example, T for thickness. And you can give it a value, for example, the 15 that we had before. And then you will see here in the list, the parameter name is equals 15. And yeah, it's 15 millimeter. You could add the units here as well if you would want that. And then here we can select all 3 of them by holding down Shift, I believe. Yes, or Control if you want to select them one by one. So Shift if you want to select from top to the last one. You hold down Shift while clicking the last element. If you want to select them one by one, it's holding down Control. And then you can change all these values in once by typing a new expression. And that expression would, of course, be the one parameter we defined. So one parameter drives all the constraints, drives all the distances that we set out to be fixed to this new parameter, this distance T. And if we animate that, you will see the animation happening. Doesn't matter if you now put it a little bit in a different order and the animation doesn't happen exactly like I have it. When you would want to fix what stays fixed and what not, you would have to apply a fixed constraint. But we will do that in the next exercise, so we will skip it for now. And then we can also try to change the thickness here by just changing the value instead of animating it. You can also change the value still afterwards. And then you see the thickness change, or maybe even 25. And then you can change it back by pressing undo or so Control Z, or by just typing in 15 again. And then we arrived at step 9, which is creating an angle constraint. So what you do for this one is you select here the icons are a little bit small. I realize that, but it's a box with like arrows in there. You can also select a face and then press or two faces, I believe, and press the constraint tab. So if you click one face and hover over the next face, you can use the quad and it will say you which constraints can possibly fit this type of selection, namely two faces. And you have here the add angle, the same icon as well. So if you do that, you either get 65, or if you maybe do it the other way around, by, I think if you press it with the ribbon, you get, oh no, sorry, that was the wrong one, this one. If you press it with the ribbon, you get the other angle. So just make sure, that it's clear for you which angle that you chose. If you do it through the quad, you will have this other part of the 180 degrees. And if you do it through the ribbon, like I did, you will have the 114, as is also mentioned in the training manual. So the training manual does it through the ribbon probably. And then we can accept that value, and we can try to see what it does if we change it. So if we change this to 120, you will see that it changes locations, but the holes are not perpendicular anymore. In fact, if you look closely to it. So I just undo that step. Make sure you don't undo too much. You want to keep the constraint in place. And while this constraint is in place, you can click the design intent option, which is step 11 in the training manual. You say that you want to keep these cylindrical faces perpendicular to this face by checking the perpendicular cylinders option in the design intent. And you can also add the perpendicular planes for example, this plane and the bottom plane, or the top plane and this plane, so that the design intent is recognized. So you intend to keep always the circles perpendicular to the faces. Also, if you change it, and if we now change it, the value to 120, it will rotate also the faces in there if you look closely. Then we're almost finished, I think, with this exercise, and we are still wanting to apply an equal radius, because if we, we actually don't have a radius constraint yet. So we first want to set a radius constraint so that we can control this radius. So you want to set a radius constraint by putting here the radius option. Again, you can probably find it in the quad as well in the constraint tab, and then you have the add radius. And then you just accept the current value. And once you did that, you can try to animate it, but it will not do 100% what you want, because actually we want always to keep these two holes in sync. So what we do to achieve that is the equal radius option in the design intent, to check that at this point. And if we now re-animate the element, you will see that they move in sync. All right. And then also what happens now is whenever you would move a face, or we would try to move it with DM move, such as is set in the sorry, I need to first put another design intent on. So now we have that they move in sync. So if we animate them, they move in sync. But if I try to move this hole with the move command, so in the quad, I use the move command, then I can hover over a site here so that my dynamic UCS is shown with the y-axis upwards. And I can, or with like nicely perpendicular axis, let's say. And if I then choose the geometric center and I try to move this one upwards by holding shift, or sideways by holding shift, you see that actually it's only one of the holes moving. It's not what I want. I actually want it to come along. And to do that, you can, I also wanted to come along with this outer cylindrical surface. And you can do that by putting on the coaxial surfaces design intent. And if you now redo that exercise, which I just did, you can enter a base point, for example, locking even the dynamic UCS with shift. I will explain that again later. And then, yeah, you can see that now all my cylindrical faces move simultaneously. You might want to press down shift to achieve this behavior, or you might want to put on your ortho mode before trying this. And then that's it for this exercise. And I will continue with the last exercise we will do also in in the next breakout rooms. And that is the parameters exercise. So for this one, you can go again to BricsCAD 24/7. And you can use the panel this time. You don't have to search it on your computer because, yeah, last time you could not import, or maybe you can drag and drop. I actually don't know. But last time we searched on our computers. This time we can just use the panel and we go to 4 parameters. And then we just open this. We download it. I will make sure that I have the same version as you. So I download it again. And then you have the ribs, no params. And what we want to achieve with this exercise is that once we make this part longer, the ribs stay nicely distributed over the length of this, of this part. And we also want to control the thickness of all these stiffeners with one go. So how do we do that? We already see some distance constraints here. You can check them out. You can see what they mean. You see that we placed 3 distance constraints for each of the stiffeners. But if you look closely on the other side, we also have stiffeners. So again, we will use design intent to achieve what we actually want. And that is that this face and this face always stay coincident as a plane. So what we do for this one is checking that here the coincidence planes is on. So it was not on with me. So I click it on this design intent. And then the first task is to change the thickness of each rib with one value. So again, we will need a parameter for this. So remember, right click on the top name of the mechanical browser, add new parameter. And then we can give it, for example, name W, as is mentioned in the training manual. And we can give it an expression, namely 20, because that's the expression we wanted to have in all of these cases. And again, hold down shift to select them all 3 in just in 2 clicks. And then you can give in the value W for the expression instead of 20. And now if we animate this W, you will see that they move in sync. But just to check everything works properly, we will also make this 40 in the expression rather than 20. And we will check that the other faces are also, or the other stiffeners are also became thicker. And that is the case. So I'm happy with that. That was what I intended, and design intent helped me with that. Then now we are going to change the overall length of the part. So we want to keep the distance between all these parts. How do we do that? Well, we make a new parameter that says distance is, and then the overall length of this element, which was distance 1, divided in 3 parts, because that's like how many intermediate steps you have. You have 1, 2. You have 1. Wait, let me rephrase. The distance between each of these of this elements should be a third of the overall distance of your part. And that's what we will do. We will say that the distance here is actually a distance 1. So you can, oh, sorry, I'm typing in my command line. So I should type here in the expression field. I can type in the name of a constraint here, or I can type in the name of another parameter here. So I can type distance 1. And I want to divide this in 3 pieces. So I do divide, just a mathematical operation, by 3, and that will give us a certain value. Like you can see, distance 1 was 300. Now, if I check it, you can see here the value in this value field, that is 100. So our expression works. And then you see here that we have always from one piece to another piece, you have 100 for 2 of them at least. So we add this expression of just the distance, like a third of the entire division. We add it here in the expression field. And now again, we can animate it. And you see that, yeah, if we animate this, of course, it will not be equal anymore. And if you look closely, actually, it's not nicely in the middle yet. So we will fix that. How do we do that? We will change the expression of this 40. So this one should actually be also one of the distances, but then like this distance. So the parameter name divided minus the thickness of one of these elements divided by 2. So why is that? Well, we want to have the overall distance from this face to this face. That's from this face to this face is 1/3. 1/3 of the model. Well, it needs to also be distributed. Like if you do it minus one of the thicknesses, you have actually what you need to put it nicely in the middle. If you divide this overall distance minus 1 flange thickness, and you divide that by 2. So that's how you do that. You change, you can use brackets to do mathematical operations in the correct order. So you do D minus W divided by 2. And then you will see it moves nicely to the middle as we expected. Of course, you can make the same approach with different expressions or different formulas, but this is an easy way to get there. And then you might want to change now the overall distance 1. You might want to change it just to see what happens to 500, for example. And then you see it still stays nicely distributed. Each of these elements is placed at 1/3 of the entire length, and our entire length minus the thickness of the flange is nicely distributed among the rest here. So that's it. And I think we're done with this exercise, and we can move to the breakout rooms. Just let me check how long you have for this. So normally we started at 10, so it was 1 hour. So we have 20 minutes left to practice on your own. I hope I went slow enough so that you could already follow some steps. But if you have extra questions, you can now join the breakout rooms that Anna Maria will assign you to shortly. And then we see you back here at 11 CET or whatever time zone you might be in 20 minutes.